Hi guys, today we are going to solve the LeetCode problem. I have already uploaded that uh, problem of the day of Geeks for Geeks. Check out that. And now we are going to solve the LeetCode's daily streak problem. And today we are having design circular DQ. So it's kind of a good data structure to use. Now we are going to implement that, and it's a the difficulty level of the problem is medium. And now we are going to design and implement the circular double-ended queue. So it's a DQ as said. So we are going to implement the MyCircularDeque class as it is given here, and the MyCircularDeque will take an argument k, initialize the DQ with a maximum size of k, and the boolean insert front. The function adds an item at the front of DQ and returns true if the operation is successful or false otherwise. Okay. Then again there is another function called insertLast, and it's also returning the boolean value. It adds an item at the rear of the DQ. So it returns true if the operation is successful or otherwise false. So there is another function called deleteFront. So it's also a boolean and deletes an item from the front of DQ, returns true if the operation is successful or false otherwise. And okay, there are certain number of functions actually. So there's other function called deleteLast, and it deletes an item from the rear of the DQ. It returns true if the operation is successful or false otherwise. In the same way, we having getFront function. It returns the integer value, returns the front item from the DQ, and returns -1 if the queue is empty. So getRear, it also returns an integer value. It returns the last item from DQ. It returns -1 if the queue is empty. Okay, fine. There are two more functions. IsEmpty, it returns a boolean value. It returns true if the queue is empty or false otherwise. IsFull, it also returns the boolean value. It returns true if the queue is full or false otherwise. So here we are having the input and output as well. So this is the explanation basically. So it initializes the function insertLast. The insertLast function is going to be implemented here. So here we can see the explanation MyCircularDeque. So we are going to initialize the queue with a 3 value 3. Then we are going to insert the element 1 at the last. As it is being successful and inserted, it returns the true. And again we are having the insertLast function is being implemented, and here we are going to insert the value 2 at the rear of the queue. So the it returns true. Then again we are having the insertFront function to be implemented. It is going to insert the value 3 at the front of the queue. So we are going to return true. Then again we are having insertFront again. We are going to insert the value 4, as the size of the queue is already mentioned as 3 only. The 3 elements are inserted, that is 1 2 3 and 3. When we are going to try insert the 4 at the front of the queue, we are going to return false as the queue is already full. Then again we are going to implement the function getRear. So getRear function takes no arguments, it just gives out the value which is at the last of the or at the rear end of the queue. So here we are going to have the 2 as the last element. Then again we are going to implement the function isFull. It does return the value boolean value. So it just checks whether the queue is full or not. So that is, if the queue size is same as the initialized size, so it is going to return true. Then again we are going to implement the function deleteLast. DeleteLast function basically deletes the last element of the queue. So it returns the boolean value if the operation is successful only. Then again we are going to implement the function insertFront. So here it takes the value 4 and gets inserted into the queue. Now here this operation gets successful because previously we have implemented the function deleteLast, where the last element of the queue is deleted, and therefore the size of the queue will be uh, 2. Then we will be having one extra space left, so that we can insert any other element. So here we are implementing the function insertFront, where we are inserting the value 4, therefore it returns true. Then again we are going to execute the function getFront, where it returns the value 4. So here we are having the constraints like 1 less than equals k less than equals 1000, 0 less than equals value less than equals 1000. So here at most 2000 calls will be made to insert front, insert last, delete front, delete last, get front, get rear, is empty, is full. So that's a lot of calls to be made, like, see. So basically to solve this program we'll have different approaches, but I have chosen one approach. We can use a list with a fixed size k, and we can use two pointers, front and rear, to keep track of where to insert and delete the elements. So the front pointer basically points to the position where elements are added or removed from the front, and the rear pointer handles the rear of the DQ as the front does at the front portion. So the circular nature is managed by taking the modulo of the index with the k to loop back to the start when reaching the end. So basically, if you reach the end again, the end equals start. Okay, here in the circular thing. So here we are having a task to implement this circular queue. So let's check the code and see if we will be able to solve it in the first attempt itself only. So let's see what else we can do. First of all, okay, let's write the init function. So let's write self dot k equals k. It is the maximum size of the DQ. So then self dot DQ equals -1. We are just initializing the DQ with a -1 for each element. That is, the size of the DQ is, let's say if it is 3, therefore the DQ with size 3, that is the 0th index is filled with -1, the first index is filled with -1, and also the second index is also filled with -1. Then we will have self dot front equals 0. This is the front pointer we are initializing. Okay, there's typo. Then again we will have self dot rear equals to 0. It is a rear pointer. And then self dot size equals to 0. It is the current size of the DQ. Okay, now let's see the insert front function. What? Okay, so if self dot is full, okay, if the queue is already full, that is it has reached the maximum size, then we have to return false, because we have no other choice, empty position to insert a new element in the front. So we have written the false. Then again self dot front equal to self dot front -1 percentile self dot k. So we are going to move front pointer circularly. So this is the formula to move that. Then again self dot dq of self dot front equals value. Okay, we are just inserting the value at the front of the queue. Then again we are just incrementing the size of the current pointer, or the size value where we will store the how many elements are in the queue. Okay, then we are going to return true. Okay, this is how the insert front function will be executed. Then let's check about the insert last function. Here also we need to check if the queue is already full. If self dot is full, then we are going to return false, because we don't have any other place to insert a new element. Okay, then again self dot dq of self dot rear. We are just inserting the value at the rear end of the queue. Okay, we have inserted the value. Then again self dot rear equals self dot rear plus 1, then percentile self dot k. So we are just moving the rear pointer circularly again. Then again we are just incrementing the size value by 1. Then we are going to return true. This is how the insert last function works. Then we'll check the next function. Okay, we have the delete front function here. So let me just collapse this totally. Okay, we have the delete front function here. Then we have to check here, as we have in the previous functions, as we have inserted the elements both in the front and the rear ends, we have to check whether the queue is full or not. If there are any empty space left, we could be able to insert a new element either in the front or last. But to delete an element from the queue, we have to check that whether the queue is empty or not. Let's say if the queue is empty, we can't able to delete an element because we cannot be able to take out a null value, right? So we have to return false. If the queue is not empty, then self dot front equals self dot front plus 1 percentile self dot k. So here moving the front pointer circularly again, as we have deleted the element from the queue, then we are just going to decrement the value by 1 of the size value, right? So then again we are going to return true as the operation is successful. So now we have the delete last function. Let's see. In the same way, we have to check the list is empty or not. If self dot is empty, then we have to just return false. If the list is not empty, then we have to just self dot rear equals self dot rear plus 1. Then we have to make the percentile self dot k. Then again here we are also moving the array pointer circularly again. As we have deleted the element, we have to decrement the size value by 1. Then we have to return true. Okay, then we have getFront function. Okay, getFront function basically prints out the integer value that is at the front of the queue. Here we have to check if the queue is empty or not, because if the queue is empty, we cannot be able to delete any print any element that is in the queue. So if the queue is basically empty, we are checking if self dot is empty, then we are just going to return -1. Okay, because here we have been asked to return -1 if the queue is empty. Okay, we are just going to return -1. If the queue is not empty, then we are just going to return the first element self dot deque self dot front. That's it. Then now we have the getRear function. Same, we have to check if the queue is empty or not. If self dot is empty, then here we have to return again -1. As you can see here, if it returns the last items from the deque, we have to return -1 if the deque is empty. Okay, if the deque is empty, we are going to just return -1 again. Then we have to return the last element, right? Return self dot deque of self dot. Okay, we are just returning the last value, right? Return self dot deque. Okay, we have to move the pointer also basically. So self dot rear -1 plus self dot k percentile self dot k, because as we have need to print the last element, we just need to move the pointer also. That's why now we have the function is empty. So basically return self dot size equals to 0. So this what does this line actually mean? Because we have we have a variable size. as if the element is being inserted into the queue, we are just incrementing it. This shows that the size of the queue. So if we are deleting the element, we are also decrementing the value of the size. This shows that what is the size of queue and how many more elements can be added. Okay. So basically the isEmpty function is going to return the bool value here. We are checking that if the size equals to 0, then basically it returns true. If the size is not equals to 0, it returns false. That's it. We don't need to do it any further things. Okay, is full. Okay, now we have just need to check whether return self dot size double equals k. So if the size is equals to k, that when all the elements are inserted and there is no more place to insert, it means that the queue has reached the maximum number of size to be inserted any other element. So k is the maximum number of value to be inserted. K is the maximum number of items to be inserted into the queue. So if size equals to k, we don't have any other extra space to insert a new element. So this function is basically to check to insert an element both in the front or in the rear. So isEmpty function is basically used to for the deleting of the item or showing or displaying front end and the rear end. So now let's try to run the code. Let's see whether it works or not. Okay, name k is not defined. Let's see what's the error. Okay, my bad. We need to use it using the self dot k. Okay, now let me run it. Yeah, the sample test case is working perfectly fine and it has accepted and the runtime is 34 ms. So let me try to submit the code. Now I'll see whether the code works perfectly or not. Yes, okay, okay, wrong answer, and there are only 9 by 51 test cases passed. Let me see where it's going wrong. Okay, it's returning correct till here and it's returning -1, whereas it needs to be returned 0. uh, Let me check where I have gone wrong. It's getRear value. Let's see getRear. Where is the getRear function? Okay, it's here. Is empty. I'm checking that whether it is empty or not. Okay. So the main number of elements to be inserted is 5. Okay. 1, 2, and okay. InsertFront, insertLast, getFront. Okay, it returns 7. Then inserting 4, inserting 5. Okay. Then all these needs to be true. Okay, then getRear, we are just printing -1 whereas it has to be printed 0. Okay, I need to check where I have been going wrong. Give me a sec, guys. So the error we had in the getRear function was here. So due to that formula, it was not working very good. So I have changed the code here. So this is this block here, it is going to wrap around till the last valid element, and here we are just going to print it. Okay, we are just going to take the pointer kind of thing. Okay, here we are getting the last element and here we are just moving around till the last valid element, and let's see if this works now. Okay, the public test case is working good. Let me see if I could get it. Still the wrong answer. Okay, let me try other code. As you can see here, the code has executed perfectly fine. There were some minor mistakes I have done. So just check out these. So I'm just initializing the Deque with -1 and this is going to keep track of the current number of elements. So these are the front and rear pointers and this is the k value. So here we are just going in this insert front, we are just inserting the element into the front. So this is the piece of code that I have changed, and these are the things that have changed. The same value is written, but instead of writing in the form of values, I have used the if and else conditions here. In the same manner I have done it here also. Instead of using the formulas, I have done it here. I might think that the formula is going somewhere a little bit of kind of error, so instead of going with the formula kind of thing, I have done with the if and else things. So now it's perfectly working fine, and it's beats the 54.99% of the users, and it's just working damn good. Okay, thank you for watching, guys. Do subscribe for daily updates on the LeetCode and Geeks for Geeks problem of the day, and as well daily streak on the Lead Code. Okay, thank you.